Hello friends, welcome back to your UPSC. So today we'll start with our another topic of geomorphology, that is geosyncline. So let's get started. So, geosyncline. Our geological history of continent and ocean basins denote that our globe, that is our earth, is characterized by two important features. What are those two important features? They are rigid masses and geosyncline. So the continents and ocean basins are denoted by rigid masses and geosynclines. Rigid masses represent the ancient nuclei of the present continents, okay, which have remained stable for considerably longer period of time. Okay, so these rigid masses are ancient nuclei of present day continents, okay, which have remained stable for longer period of time. Then our geosyncline. We have various definitions of geosyncline, but basic characteristics of geosynclines are: firstly, they are long, narrow, shallow depressions of water. Okay. Secondly, they are sorry, they are formed due to gradual sedimentation and subsidence. Okay. Third, they are actually not, they don't remain same. They are constantly changing due to Earth's movement and geological processes. Okay, like compression or diversion of plates. Okay. Fourth, they are mobile zones of water. And last, they are bordered by two rigid masses. Okay, so this is a geosyncline. Okay, this is water. So these are two rigid masses which are known as forelands. So this mass and this mass will be known as foreland. So as now we have understood what exactly are geosynclines and rigid masses, we will study about the concept of their evolution, okay, and the theories related to them. So this concept was first given by James Hall and Dana, okay, but it was further elaborated and developed by Hawke, Steers, etc. So first we will study about the concept given by Hall and Dana. So Dana actually studied the folded mountain, and he actually realized that the rocks in the folded mountains were made up of marine, okay, marine sediments or marine elements, okay. So it was of marine origin. The rocks were deposited in long, narrow and shallow sea called geosyncline, okay. So actually what he said was these folded mountains are formed by compression of this geosyncline. This geosyncline was is long, narrow, shallow. Okay. He said that this geosyncline is long, narrow, shallow, and sinking bed of sea. Okay, which was deposited. Okay, and this compressed to form folded mountains, and therefore these folded mountains have marine origin. Okay, and Hall, in support of this theory of Dana, he said that he proved the relation between a geosyncline and folded mountain. He said that due to continuous sedimentation, geosyncline subsided, but the depth of the water in geosyncline remained the same. Okay, so he said that, see, this is the exact diagram what he told. Firstly, this is the shallow sea, okay, shallow water. Due to sedimentation, this part is becoming heavy, so it subsides. Okay, then again due to sedimentation, this parts also become heavy and this also subsides. And like this, it subsides, and this is the subsidence of the floor. Okay, and due to this subsidence, there is lot of this subsiding, this sedimentary material or whatever, this marine material is collected here. But the depth, see this depth of the water, it remains the same. So what Hall said, that the depth of the geosyncline remained the same, and due to sedimentation, the geosyncline subsided. Okay, so this whole material was sedimentary. Okay, and this sedimentary material, when was compressed, it formed folded mountains. Okay, so this was the concept of Hall and Dana. Now next, we come to the concept of EHOG. EHOG said that geosynclines are deep water areas and they are much longer than they are wide. Okay, so they are like their length is more and their width is much less than their length. Okay, he drew a paleographical paleogeographical map. Okay, and he identified five rigid masses of Mesozoic era. Okay, so in geographical map, he identified five rigid masses of Mesozoic era and four geosyncline between these rigid masses. And how did he identified these five rigid masses and these geosynclines? Was he saw the placement of present day folded mountains. Okay, and according to that, he actually identified five rigid masses and four geosynclines. Okay, so these rigid masses are, first is North Atlantic continent or North Atlantic mass. Second is Africa Brazil continent or Africa Brazil mass. Third is Sino-Siberian continent. And fourth is Australia, Indian, and Madagascar. Australia, Indian, and Madagascar. These are Madagascar, Mascani Islands. Okay, Madagascar continents. So these are the four rigid masses. And there is one more, sorry, Pacific. So there are five: North Atlantic, Africa Brazil, Sino Siberian, Australia Indian, Madagascar continent, and Pacific. And he identified four geosynclines, that is Rockies, Ural, Tethys, and Circum-Pacific geosyncline. Okay, okay. So this is our Pacific continent. It extends from here, here, and these four geosynclines are, this is Rocky geosyncline. Okay, then is Ural. Here is Ural geosyncline. Then is Tethys geosyncline. Tethys geosyncline extends from here till here. Okay, this whole is Tethys geosyncline. And Circum-Pacific geosyncline. This is Circum-Pacific geosyncline. Okay, he said that these littoral margins, they were affected by transgressional and regressional phases of the sea. Okay, and it is not necessary that all these geosyncline passes through complete cycle of, what was the complete cycle? That is the cycle of sedimentation, subsidence, and consequent orogenesis. Okay, so this was the concept given by EHOG. Now let's move to another concept. Now next is the concept of Schuchert. He classified geosynclines on the basis of their characteristics related to their size, location, and evolutionary history. Okay, so he classified these geosynclines on these characteristics, and he divided them into three categories according to these characteristics. Okay, so these categories were monogeosyncline, polygeosynclines, and mesogeosynclines. So monogeosynclines, they were long, narrow, but shallow water tracts. Okay, they were subjected to continuous subsidence due to gradual sedimentation and resultant load. So they were continuously subsiding. Okay, they were either within continents or along the borders. So, they are either inside the continent or along their borders. Okay, and they are called monogeosynclines. Okay, monogeosyncline because they have passed only through one cycle. I told you what actually the cycle is. Cycle is sedimentation, subsidence, and consequent orogenesis. Okay, so they have passed through only one cycle, one, that is mono. Okay, so one cycle. And the best example for this is Appalachian geosyncline. Okay, Appalachian geosyncline is in USA, Appalachian mountain. Okay, now polygeosyncline, as the word suggests, poly means many, so it has passed through more than one phases of orogenesis. Okay, then other characteristics are it is long and wide water body. Okay, so this one was shallow and narrow, but this is wide. It has more defined boundary, and it existed longer period of time than that of monogeosyncline. Okay, next is its examples are Rocky and Ural geosynclines. The last one is mesogeosyncline. Mesogeosyncline is it is long, narrow, and mobile ocean basin, and it is bordered by continents from all sides. Okay, for example, the one which is in Mediterranean Sea. Okay, it has great abyssal depth. Okay, it is very deep, and it passes through several geosynclinal phases. Okay, and so the best example for this is Tethys geosyncline. Okay, so we don't have Tethys geosyncline now. The remnant of Tethys geosyncline is in Mediterranean Sea. Okay, so mountain ranges like Alps and Himalayas were formed by Tethys geosynclines. Okay, so this was the example of mesogeosynclines. Now let's head on to the last concept, that is the concept of Arthur Holmes. Okay, so like Schucher, he also elaborated the cause of origin of different type of geosynclines, and he also described the detailed process and mechanism of sedimentation, subsidence, and consequent orogenesis. Okay, so he identified four major types of geosynclines. Okay, and he described them on the mode of their origin separately. Okay, so these types of geosynclines were formed due to first was formed due to migration of magma. So as we all know, there are three layers. Okay, so he said that there are three layers. First is the upper crust, then is intermediate layer where magma is present, then is the lower layer. So due to this movement of magma, that is the intermediate layer, the upper layer moves. Okay, so there is a movement in upper layer due to the migration of this magma, and because of which the plates collapses with each other and subside. Okay, so whenever the plates will collapse with each other, they will subside. One of the plate will subside if they are like one is heavy and one is lighter. Okay, thus forming geosynclines. Okay, next was metamorphism. So in this he said that metamorphism was caused due to compression of converging plates. So there are two plates. Okay, there are two plates which are converging. Okay, so these converging boundaries, plate boundaries, okay, these are two plates which are converging. So these converging plate boundary will increase the density of the rock because they are converging. So the density of this rock will increase, which will result into subsidence of the lower layer of crust. So whenever the density will increase, it will subside. Okay, and thus forming geosyncline. Okay, next is due to compression. So compression is like same like metamorphism. Okay, so the convergent convective currents cause compression of the outer layer of crust. Okay, and because of which this layer subsides. Okay, and thus forming geosynclines. So there are converging currents. Okay, so because of which the outer layer of crust is compressed and which subsides, because of which it subsides, and thus forming a geosyncline. And the next one is thinning of cealic layer. Cealic layer is uppermost layer. Okay, so below the sedimentary layer there is a ceal. Okay, we have studied it in previous class. There is ceal. So this ceal can be sorry, there is a thinning in the cealic layer which can be caused due to two reasons. First is due to stretching apart of the layer by divergent convective currents. Okay, first is either they are stretched apart by divergent convective currents, or there is a separation of continental masses because of divergent convective currents. Okay, so these are the four reasons of formation of geosynclines. So these are the four types of geosynclines, and now we will see or look into the stages of geosyncline. So there are three stages of geosyncline. First is lithogenesis, second is orogenesis, and last one is klyptogenesis. What happens in lithogenesis there is creation of geosyncline. How is geosyncline formed? Okay, so here we have landmass. Okay, and here is this shallow water body. Okay, so it is like this shallow. Now what happens due to the sedimentation of from the rivers, or anyhow there is sedimentation. This is water, sea floor level. Okay, so there is sedimentation. So due to this sedimentation, this part become heavy and it subsides. It subsides down and then it come here. Due to further more sedimentation, this part become again heavy and this subsides. So like this, there is a formation of geosyncline. Okay, due to subsidence and sedimentation. Now, in the next stage is this orogenetic stage. In this stage, what happens is this is the stage of squeezing and folding. So now we have our geosyncline formed. Okay, now there is compression from both sides, and because of this compression, this part, okay, this material, it rises up and it forms the folded mountains. Okay, so this is squeezing and folding. This was orogenesis, and the last stage is glyptogenesis. This is the stage of gradual rise of mountains. So here what happens is due to compressional forces, the mountain are rising. Okay, the mountain is rising. Mountains are rising. Sorry, this diagram is really pathetic. These are the two masses. Okay, these are the two continental masses. Due to compression, there is a rise in mountain. Okay, but there is also erosional and denudational processes taking place. Okay, so here what was happening, the orogenetic or the squeezing was faster. Here denudation is faster. Okay, so in this last stage there is a gradual rise of mountains. Okay, so these are the stages of geosyncline, and this was the concept of Arthur Holmes. With this we come to the end of our lecture today, that is geosyncline. So guys, that was all for today. I hope you enjoyed the lecture. So let's meet in our next class. Till then, take care and have a nice day.